Application is correct if it acts as specified. It is robust if it can take high load until it goes down. Application is resilient if it can go back to normal after disruption. Hi everyone, my name is Bobur. I'm a developer advocate. In this video tutorial, we describe how an API gateway like Apache APISIX is useful for testing the robustness and resiliency of microservices APIs. So after the post, we get to know types of possible failure injections with a fault injection plugin, and we simulate failures on our existing product backend service developed by using ASP.NET Core Web API. Distributed systems such as microservices have led to increase in the complexity of the systems we work with. It's difficult to have a full confidence in the architecture when there are many components and a lot of moving parts that could potentially fail. And it is critical to handle failures and service-to-service calls gracefully. Also, we want to be sure that any resilience mechanisms we have in place, such as error handling or circuit breaker, health checks, retrieve, fallback, redundant instance, and so on, we can verify this with the help of testing method called fault injection. The fault injection approach at the API gateway level can be used to test the resiliency of application or microservices APIs against a various form of failures to build confidence in the production environment. The technique can be used to inject delays or abort requests with a user-specified error codes, thereby providing the ability to stage different failure scenarios such as service failures, service overloads, high network latency, network partitions, etc. Apache APISIX fault injection plugin also offers a mechanism to inject some errors into our APIs and ensure that our resiliency measures are effective. APISIX works in two different modes, both configured using the fault injection plugin, like delays or aborts. Let's suppose that we have an online app, a shopping sample application that consists of many microservices such as catalog, product, order, and more. We are retrieving data about products belonging to a specific catalog. There will be service-to-service interaction between catalog and product service. In this case, something might go wrong due to any number of reasons. To test this shopping application's microservice for resiliency, we are going to simulate the product service misbehaving as a faulty service, like by adding a delay to the HTTP request or by aborting the HTTP request and returning just a custom status code. For the demonstration, we are going to use Apache APISIX fault injection plugin. You can find under plugin section on APISIX website for detailed instruction on how to configure delays and aborts, see the fault injection and documentation. You can see the complete source code for our sample application on GitHub and see the instruction on how to build the multi-container APISIX with your Docker CLI. Once you git clone the repo from GitHub, you can open the project folder and go to APISIX config folder, open the config.yaml file. And here we need to register the plugin we would like to use. In our cases, it's fault injection. Then you can run the APISIX with the services we have. Get the Docker compose up. It will bring all the necessary services we have. As you can see, the APISIX.NET Docker project is up and running. In my case, I'm using Windows operating system and I have Docker desktop installed. You can see some following services are up and running, including our backend sample application product API. In the first example, we introduce a 5-second delay for every request to the product service to test if we correctly set a connection timeout for calls to the product service from the catalog service. The following route configuration example creates a new upstream for our backend service product API, and that runs on port 80 and registers a route with the fault injection plugin enabled. You can notice that we set the delay injection in the plugin settings like 5 seconds. If you hit the command and run, you will get successful response from admin API of APISIX. So below we confirm the rule was created by running another curl command with a time measurement. If you press enter and run this command, it takes a couple of time, like 5 seconds. After you run the command, you will see there is some delay was introduced. So the result of fault injection as we expected. In the next example, we'll introduce HTTP abort to the product's microservice to check how our imaginary catalog service responds immediately to the failures introduced by dependent service such as product. Let's say when product service fails, we should expect HTTP error with a product service and a currently unavailable error message. We can test it in action. Now we can enable abort injection with the following route configuration. If you run this command, you will get another successful response from the APISIX. Now, if you run curl command to hit the APISIX route, now it quickly responds with HTTP 503 error, which in turn very comfortable to test catalog service. How it reacts such kind of server errors from the downstream services. You can see the product service is currently unavailable error, we got it. With that, we can finalize our demo example.